is review problem number 8. Why does calcium fluoride have a higher boiling point than ammonia? All right, so we're talking about boiling point. So the first thing I'm thinking is, what's the difference in boiling point? Particles that have a higher boiling point have greater attractive forces. Okay, so that is going to be the secret to this problem. What are the attractive forces in calcium fluoride and ammonia? All right, so let's identify, basically, what are we talking about? IMFs, right? IMFs. Okay, so calcium fluoride is ionic, and so what holds it together? We have ionic bonds. That's it. It is crystalline structure, ionic bonds. And you need to know that. That's a metal and a non-metal ionic bonding all day. Strong forces, okay? And then ammonia is a molecule, and I'm just going to draw it real quick. It looks like this, and it is a dipole, okay? So it has dipole-dipole forces, of course, dispersion forces, which are relatively weak. And then does it have hydrogen bonding? It does. So we also have hydrogen bonding, which is a very strong force, okay? So if I didn't know which had the higher boiling point, I wouldn't really be able to decide, because ionic bonds are very strong, but so are dipole-dipole and hydrogen bonding. But the problem tells us that we have a higher boiling point for the calcium fluoride. So the question is why? So let's see if we can remove some of these options. Calcium fluoride is more massive and stronger London dispersion. That's silly. Okay, not London, it's ionic. All right, covalent network, nope. Calcium fluoride is smaller and has greater Coulombic attractive forces. Maybe, actually, I think it's larger, so let's not look at that. Calcium fluoride is an ionic substance, and a great deal of energy is required to break up the ionic lattice. It has to be that one. It is not smaller, it's actually a larger compound. So there you go. I hope that helps. Good review problem. IMFs, make sure you are able to identify them and then compare their relative strengths and how it impacts physical properties like boiling point.